Good morning.
Good morning.
All right, seems like forever since I've seen you guys, so glad to be here. So is Ellie not here? Is she here?
She's here.
Oh, okay. All right, and then is how about Joseph City? Is Auburn there? Who's
I don't think Auburn or Caden are here. Oh, is she?
Yeah.
I don't know.
wait,
Auburn's here, Caden's gone.
So just Caden, okay. All right. All right, and then how about
Caden just got here.
okay, just got there? Okay, thanks. How about in Winslow? Who's absent today?
Just Andrew.
All right, thank you. All right, so so I looked over the notes that Mr. Fritz did with you guys, and so I'm going to try to maybe go over the sheets, the guided notes, and just kind of make sure that you don't have any questions. So today I'm just going to be kind of maybe filling in any gaps from 8.4, 8.5, and 8.6, maybe, or we'll just do 8.4. I don't know how far we'll get, but if you want to start out getting out the guided notes for 8.4, and we'll kind of start there, and I just want to go through and then if there was any questions that you had on the stuff that he taught, I want to make sure that I'm able to go over that with you. The other thing, I did want you to know that we did have all our interviews yesterday or last week for the new VP for MPC. So hopefully we'll be finalizing that tomorrow. And anyway, but I think it was a good process. So while I hated missing class, I think if we get the candidate that we want, it's going to be well worth it because the VP actually is going to be over the talent program is one of the things. So so it actually directly relates to those of you that are juniors and might be taking talent courses next year. It could have a direct impact on you. So anyway, so we'll see how that goes. All right. So where I have us left off as far as taking notes on 8.4 was right here. So if you want to look and you guys correct me if I'm wrong, if I've got that messed up, but we were kind of in that last little part on 8.4, and I don't think I think Mr. Fritz started with 8.5, so so please, if I'm wrong, let me know. But if you look at the 8.4 sheet, at the very bottom of that last column, well, so we just have one column to go. He didn't go through that stuff, did he, on graphing and Euler's form?
He did Euler's form, but not, we didn't graph them.
You didn't graph it? Did you multiply with Euler's form?
Yeah.
Oh, okay. Well, then this is going to be easy. Okay. So the behavior of multiplication and division of complex numbers also manifests itself in the graphs. And so just to kind of remind you how the graphs are, And so if he went over the Euler's formula, and the blank for this is actually right above part 5, where it says roots of complex numbers. This is Euler's formula, AE to the I times the angle. And so it's just another way. It's like the trig form and the CIS form. You put the magnitude in front, and then the angle up here is part of the exponent. And so the graph, so let's say I wanted to graph these two and their product. Okay. Now, to remind you how we multiply in trig form, you multiply the numbers in front and then you add the angles. You don't multiply the angles, you add the angles. Okay? So the product of these two would be 4 times a half is 2, and then CIS, and then you add the angle and get 90. Okay? And then so how you graph them, so this 4 CIS 15 in Euler's form is just 4e raised to the I 15 degrees. So you go up 15 degrees and then you go out 4 radiuses. So 1, 2, 3, 4. 1/2 CIS 75, that's the same thing as 1/2 e to the I times 75 degrees. So you go up 75 degrees, which is right here, and then a half, so you go out half of a circle. And then when you multiply those together, the 2 EI 90, so 90 degrees, and then you go out 2 radii. Okay? All right, so I'll leave this up here. You guys try practice 3C. And see if you can
Mr.
do
Strong,
it. Yes.
when Mr. Fritz taught us, he told us that usually the theta is in radians. Do you want it mostly in radians or degrees?
It's whatever works for you. Okay. There are a lot of applications that are in radians, but there's also some that are in degrees as well. So really, whichever works for you. If you want to convert it to radians, that's good. Okay, so just looking at these. So the first one, this is just a rough sketch. Okay, so 3 EI 30 degrees. So you go out 30 degrees and then 1, 2, 3 radii. And then EI 60 degrees, you go up 60 degrees and then just 1 radii because the coefficient is 1. And then when you multiply those together, 3 times 1 is 3 EI. Add the angles and you get 90 degrees. And so you go up 90 degrees and then out 1, 2, 3. Okay? All right. Any questions on that one? All right. And then did you guys do De Moivre's theorem?
Yeah.
Okay. So
No.
did you do practice 4?
No.
Okay. So let's just again, I don't think it hurts us to go through and review this. Okay. So when you have De Moivre's theorem and you have your complex number, and so this is in trig form, then, or if you're in the CIS or even Euler's form, then when you raise it to a power, the number in front is the R is what you raise to the power. And then the angle you multiply. Okay? So if you have it like in Euler's form, let's say you have let's say 3EI 20 degrees. And you're going to square that. Then you square the 3 only, and then the angle you multiply. So it'd be 20 times 2. So 3 squared would be 9, EI 40. Okay? But now the practice problem, you're actually have to put it into trig form first. Okay? So let's jump to that. How to put this in trig form or CIS when it's written in complex form? How do you do that? What 2 things do you need to find to put it in trig form or CIS or Euler's form? Any of those? What 2 pieces of information do you need? Yes.
R and tangent theta?
Yes, R and ultimately theta. So you need to find the R and the theta. So to get the R, that's the absolute value, and so it's the square root of 1 squared plus 1 squared. And so that's going to be the square root of 2. And then to get the theta, so theta is equal to, well, theta prime actually, is the inverse tangent of 1 over 1, so 45 degrees. And that's in the right quadrant. Whoops. So 45 degrees. Okay, so that's my theta. That's my R. Okay, so now see if you can raise it to the 6th power. Sorry. All right, Tiana, when you get the answer, let us know.
I got 2 CIS 270.
Okay, now, okay, the radical 2, though, the R, you have to raise that to the 6th power. And so radical 2 to the 6th power, the way I think of that is just 2 to the 3rd. So it's going to be 8. Okay? So it's actually going to be 8 and then CIS 270. Okay? Or AEI to the 270. Okay? So you have the 270 right, but the radical 2, you have to raise that to the 6th power to get 8. Okay? All right, any questions on that? On how I got the 8? Okay. All right, so that's De Moivre's theorem. Whoops. Or did you need more time on that? Writing it down? Okay. Okay, and so now to find the roots of the complex numbers. Now, now going back to kind of the comment about degrees and radians, on these, I actually much prefer them in degrees. I think it's a lot easier to do these. And really, I don't really like how the book even teaches this. So when you're finding the roots, like if you're you take the absolute value or the magnitude, and then if you're finding the fourth roots, then you take 1/4. That's the fourth root is the same as the 1/4 as an exponent. Fifth root, 1/5, so on. And then it's EI, and then it's theta divided by how many roots there are. Plus, and then you add multiples of 360 and then divide by that. But it's actually easier than that. I mean, this is the formula you can put down, but I kind of want you to see there's actually a pattern here that's easier to use than the formula. And so I kind of want to go through that with you. But go ahead and write that down in the blank under part 5 there. At least this is the formula in degrees. This is the formula in radians. But I'm hoping that you'll see a pattern here. Okay, so all right. So here, let's say we want to find the fourth roots. Find all the fourth roots of -1 minus I radical 3. Okay, so the first thing you need to do is put it in trig form. So you got to have the r and the theta each time. Okay, so the r, you say that's the actually I think I did that one in earlier, but -1 squared and plus -1 squared, add them up and take the square root, and so you're going to get 2 as your r. And then the theta is the inverse tangent of negative radical 3 over -1, the b over the a. And so you end up with 204. Well, actually, theta prime is 60 degrees. But that puts us, remember that this, when you do the inverse tangent, it only gives you the reference angle. So 60 degrees is in quadrant 1, but where the x and the y are both negative is quadrant 3. So you have to measure down 60 degrees from the x-axis. So that's where we get this 240. So you can either write your answer as 2 CIS 240 or in Euler's form 2 EI to the 240. So that's kind of the first step, is putting it in trig form. Okay, so I know I kind of blew through that, but would anyone need me to go through and explain that in more detail, how we get that trig form, either the magnitude or the angle? Okay, well, so now what we do is you say, okay, you're finding the fourth roots. So the coefficient in front of each one is going to be 2 to the 1/4. Okay, so whatever that number is there that you get for your r, it's going to be 2 to the 1/4. Okay, let's see here. Okay. All right, I'm actually going to just focus on the angle part. So you have the 2 to the 1/4, 2 to the 1/4, 2 to the 1/4, 2 to the 1/4 in front of all 4 answers. So if you're finding fourth roots, you're going to have 4 answers. Fifth roots, you have 5 answers, and so on. Okay, now, so the angle is going to be, you can kind of start with, well, it turns out you can actually start with your theta prime, or you can start with, so you can start with 60, or you can start with 240. It doesn't matter. It's kind of in, because it goes in a loop forever. And so what you're going to add is when you take this 240 and you divide it by 4. So 240 divided by 4 takes you back to this 60. All right, then when you add multiples of 360, 360 divided by 4 is 90. So what you actually do is add 90 to the angle each time. So 60 plus 90 is 150. 150 plus 90 is 240. 240 plus 90 is 330. Okay, and now this is the key right here. This helps you know that you're doing it right. Is the last one, if you add 90 to it again, it should take you back to where you started. That's kind of how you know you're doing them right. So 330 plus 90 would be 420, but 420 is the same thing as if you subtract 360, 420 minus 360 would be 60. So it takes you back to where you started. Okay. Now, if you, let's say you're finding the fifth roots. So if you take 360 divided by 5, then that's what you would add. Or if you're finding the third roots, it's 360 divided by 3, or 120 is what you add to the angle each time. Okay? All right, so now, so for practice 5, it says find all the fifth roots of 1. So the first thing you have to do is find the r and the angle. So see if you can put it into CIS form or Euler's form. All right, so Cameron, what would 1 be in trig form?
The first exponent, the first root.
So no, we're not doing this yet. I'm just asking you, what would the trig form of 1 be? The CIS form.
What? Could you explain it to me?
Well, it's actually kind of complicated because it's easy in a way. See, when you think about 1, well, what's the I part? If there's no I part listed, what would the angle be? Yeah, it would just be 1 plus 0I. Okay? Because there's no imaginary part. So let's go to that. If we had 1 plus 0I, okay, what's the magnitude of that? What would the R be?
1.
1. Okay? And then what would the angle be?
90 or 0?
Which one? 90 or 0?
90.
Think about where, if you were going to graph it, where would it be on the graph? Would it be on the x-axis or the y-axis?
It'd be 0.
Yes. So, because you'd go out 1, and then you wouldn't go up or down or anything. So 1 plus 0i, it would be the trig form. So the magnitude is 1, and then the angle is 0. Okay. All right. Now, let's see if you can. So the CIS or Euler's form. Let's see. So you could think of it as 1 CIS 0 degrees or 1 EI 0 degrees. Okay? All right, so that's just putting it in trig form. Now we need to answer the question. So we want to find all the fifth roots of 1. Okay? All right, so Taylor, when you've got it, or if you get stuck, let me know. If you need some help.
I'm stuck.
Okay, so the number in front is going to be this 1 to the 1/5 power. Why 1/5? Because we're finding all the fifth roots. Okay, so 1 to the 1/5 will go in front of each one. We're going to have 5 answers, okay, because they're fifth roots. So the first angle is going to be 0 degrees. All right, so now what are we going to add to that? Can anyone tell me?
360?
Okay, it's 360 divided by
5.
5. So what's 360 divided by 5?
72.
72. So if we add 72 to that, we just get 72. Okay? So, so we're going to get 1 to the 1/5. Well, 1 to any power is 1. So we're just going to get 1 EI 0. Well, anything to the 0 power is 1. So the first one just ends up simplifying to 1. The second one, we have 1 to the 1/5, which is 1, and then EI 72 degrees. So what will the next one be?
1 EI to the 144 degrees.
Yep. And then the next one.
1 EI to the 216 degrees.
And then the next one.
1 EI to the 288 degrees.
Oh. Okay. And then to check, see, that's all 5 of them. And so then to check what you do, add 72 to that, and what should you get?
360.
360, which is the same as 0. Okay? So the number in front is the R that you find to 1 over how many roots that you have. The EI is the same for all of them. And then the angle, you take the angle and then you add to it 360 divided by how many answers that you have, how many roots that you have. Okay? And you should go all the way around the circle. All right? Okay, so so are there any other questions from 8.4? Okay, so until we had this little time, and I wanted to, you notice I didn't, even though I know Mr. Fritz went over a lot of 8.3, 8.4, 8.4, 8.5, and 8.6. I didn't post any quizzes on that because I wanted us to be able to talk before we did any of that. But okay, so let's look at 8.5 now. Oops. Okay. So this was the one on vectors. It looked like you did quite a few examples on vectors and so on. Okay. So says a vector is a quantity with both magnitude and direction. Does anybody know what movie has a supervillain named Vector?
Despicable Me.
Despicable Me. Very, very good. And there's actually, I had a clip from it, but for some reason, the new version of Smartboard doesn't support Flash, and so I can't show you my clip. But I had it where, Vector explains that his name is Vector because his crimes have both magnitude and direction. Okay, that's the definition of a vector. And so you use vector quantities a lot in physics, where you're not just talking about the speed of an object, but its direction is important, the angle that it's going to, and so on. When we talk about the magnitude of the vector, it's the same thing that we've talked about before with finding absolute value. Okay, so let's see, I think this is the first. Okay, so you have a directed line segment, PQ, and so these are the first blanks on the guided notes. The P, the order of the letters is important. P is always the initial point, Q is the terminal point, and so the little arrow tells you what direction you're going. Now, this is different than a ray in geometry. It looks exactly the same, but in geometry, a ray goes on forever, but a vector does not. The vector ends at this terminal point. So at the tip of the arrowhead, it ends. It doesn't go on forever. And so all of these vectors have the same magnitude. They have the same length. Okay. Okay. All right. Now to graphically add vectors together, you start with your first vector and then you add the second one on the tip of the first one. This is called the head to tail method. Let's see, I think we have that blank there. Let's see. All right. Okay, so let's do this one. So here it says let vector u, and so you can use these bold letters to indicate the vector as well. Be represented by the directed line segment. So 0, 0 is the initial point because for vector PQ. Q is the terminal point. So the double absolute values, that means the magnitude or the length of it. So you use the distance formula. Okay? So see if you can do that for me. All right, so Cameron, what do you have?
I got stuck.
Okay, so when you're finding the distance, the magnitude, you use the distance formula. So you take the difference in the x's, so 3 minus 0 squared plus the difference in the y's, 1 minus 0 squared. And so then you subtract 3 minus 0 is 3, 1 minus 0 is 1. And so then you square the 3, 9, square the 1 and get 1. And so the answer is the square root of 10. So that's the magnitude or the distance. Okay, let's go ahead and try another one of these, just for fun. So, find the magnitude of vector PQ here. So again, use the distance formula. So this isn't one from your sheet. This is just an extra one. All right, so Ellie, when you've got it.
So in decimal form, it's 10.2, I think.
Okay. So let's see, if you have, let's see, I got 11.662.
I just put it in my calculator wrong, but yeah.
Okay. Okay. So you subtract the x's. So -3 minus 7 squared. So that's -10 squared, which is 100. Subtract the y's. 5 minus -1. So 5 plus 1 is 6. I guess I'll bet you that's where you messed up. Right in there. And so, then square root of 136 is the exact answer, and then that's approximately 11.662. Okay. All right, any questions on that? Okay. Okay, so the two basic vector operations, scalar multiplication and vector addition, and I saw that you did both of these. So geometrically, just to kind of give you a visual, the product of a vector and a scalar is the scalar times as long as the vector. So if you multiply a vector by a scalar, then it makes it longer or shorter. So like if this is vector v, then 2 times v is actually a vector that's twice as long, that goes in the same direction. So 1/2 v goes half as long in the same direction. Now, when you multiply by a negative, it also changes the direction. So if v goes like this, negative v just goes in the opposite direction. Or -3/2 v, the 3/2 makes it 3/2 as long, the negative makes it go and it flips the direction of it. So visually, that's what multiplying by a scalar does. Okay.
So, Mr. Strong, if you started with a negative vector and multiplied it by a negative, would it change to positive or still be negative?
No, it would change to positive. It would change to positive. Okay. Okay. All right, so to add two vectors geometrically, okay, this is kind of the next part. So you place the initial point, and this is what I was talking about before, the head to tail method. You place the initial point of either one at the terminal point of the other. Okay? Then you draw the vector with the same starting point and ending point. So like if you start with V and then you add U to it, then when you draw this line U plus V, then that's how to add the vectors geometrically. Now, I mean, this is extremely important when you're like in a physics class and you're doing these vectors. And, you know, like if one vector is, I think Mr. Fritz did a problem with you with the vector of a plane and then the wind. And so it helps to know, to see what's going on, okay? And so, but I think it's a little bit easier when you do them algebraically, when you do the numbers. And so that's kind of what, where I'm gonna go to next. Let's see. Okay. So before I do that, let's go ahead and do the graph of this. So first, you have to graph vector u. So this is going from P to Q. Okay. So P is the initial point. Q is the terminal point. So draw your graph starting at P and ending at Q. And then so at Q, that's where you're going to draw the arrowhead. Okay? So that's U. All right? Then you'll have the same vector. So I don't know if you've got another colored pencil or another color pen, but you might want to then, or you could draw it on another scale, but if you just had a different color, then negative U would look like what?
It would be -3, -1.
Yeah, so it would go back the other way. So if this is U here, then negative U would come back the other way. So it's the same distance, same length, just going in the opposite direction. And then to U, you just extend vector U out the same, whatever distance this is, and we're just estimating. You can use your pencil or whatever and say, okay, this is about this much, and so you just kind of go out that much again, and so then that would be 2U. So just having extending it out a little bit farther. Okay. All right. Let's see. Okay, let's jump to part 2. Actually, that should be part 3. The component form. Now, we'll come back and fill out those other ones here. Well, now here we can, well, let's do this component form. Okay, so it says a vector whose initial point is at the origin 0, 0 can be uniquely represented by the coordinates of its terminal point v1, v2. Okay, this is the component form. Written as, okay, now it's got, when it's in component form, it has these funky brackets there at the end. They're not normal parentheses or brackets. They look like that. And V1 and V2 are called the components of V. But it's these funky brackets here that let you know that you're in component form. Okay, so the component form of the vector with initial point P and terminal point Q is, all right, so how you do it is you subtract the, you start with the terminal, so Q1 minus P1, and then Q2 minus P2. And so then we call that, you can also think of that as just V1, V2. But when you subtract, it's important that it's always the terminal minus the initial. Okay? I'm going to write that down. Terminal minus the initial. And then, so once we have it in component form, then the magnitude is, we actually have saved a little step, because when we do the distance formula, the first thing you do is subtract, and see, you've already done that. And so once you have it in component form, then it's just V1 squared plus V2 squared. And I know that looks weird to have both subscripts and superscripts, exponents, on the same problem, but okay. All right, so let's see if you can do this one. Let's see, wait. No, let's do this one. All right, I guess it's pick on Ellie day. So Ellie, when you've got it.
So would it be -5, 4?
It can't be negative.
It can be. So
Oh, wait, yeah, it can. I'm sorry. So -5, 4. Let's check it out. -5, 4. I was thinking about the magnitude. The magnitude can't be negative. But yeah, the component form can. Okay? So, yeah, you take the terminal minus the initial. So -7 minus -2, comma, 9 minus 3.
whoops, I did that wrong. So it'd be 6, not 4.
Yeah, so
I did
negative 5, yeah, so yeah, negative 5, 6. Okay, so and then you got to make sure you put those special funky looking brackets there. Okay, so that lets us know that it's in component form. Okay, all right, so everybody okay with that? Any questions? Because component form, it's really the key to doing a lot of other work in vectors. So usually if you mess up on the component form, you're going to miss the problem for sure. Okay. I remember one time I gave a test where I was trying to make it easier for the students and use the same vector. And so I would do one vector and then I asked a bunch of questions about it. And the problem is the people that did this wrong and did the component form wrong. So imagine your little mistake, Ellie, and it caused you to fail an entire test because of one little math error. See, and that was pretty sad. And so what I thought was trying to help people ended up hurting people. But anyway. Okay, so okay, so here's now, let's see. So the part that we skipped in the second column is actually this, is I've got this out of order on the sheet, but it says because in component form, see, once you have the vectors in component form, to add the vectors, you just add the x components and then add the y components. And so it's super easy. It's way easier than graphing. Okay? And then if you have a scalar times a vector, you just multiply the scalar. Let's see, I have k on the sheet, but it's just ku1, comma ku2. Okay. All right. Okay. Okay, so let's see if we can do these. So I'll do the first one here. So if I have u as a vector 1, 2, and v is 3, 1, then to add the two together, not geometrically, but using the component form, then all you do then is just say 1 plus 3, you add the x components together, and then you do the y. So 2 plus 1, and so then your answer would be 4, comma 3. All right? So if we run out of time, I want you to finish up practice 3B for tomorrow. But let's do the next one if we have time. So Jordan, if you get the answer to part 2, let us know.